Hello everybody, we're getting ready to do lesson 5.7 of Geometry 1 Math Part 1. And 5.7, Reflections in Symmetry. We have a 34-point skill sheet and we have a 10-point note-taking guide here available at the email. And then here are our standards here. We got symmetry and reflections, and this is a description of the standard. Today, our bell work teachers for your students is here. What theorem or postulate, if any, can you use to show the triangles are congruent here? And then down here, find the image of the given point using these translations here for our points. Give your students 6 minutes to do this. Okay, welcome back. Here is our solution for number 1, angle, side, congruence theorem. EF is congruent to EF. We got that. Reflexive properties, so two angles and a non-included side of a triangle HUF are congruent to two angles in a corresponding non-included side of GFE. So that will be how we got two angles and we have a side. So, and then number 2 here, our shift be -2 plus 3, x plus 3. And then 3 minus 6 here, so that would become 1 and -3. So instead of -2, -2, 3, it would become 1 and -3. See, 1 and -3 down here. Okay. A reflection is a transformation that creates a mirror image. The original figure is reflected in a line called the line of reflection here. Where is our line of reflection here? Original, this would be the image here. So this is perpendicular to this line here. Line of reflection. Okay. Properties of reflection. The reflected image is congruent to the original figure. The orientation of the reflected image is reversed. The line of reflection is the perpendicular bisector of the segments joining the corresponding points. So the line of reflection is the perpendicular bisector of the segments joining the corresponding points. So students, in your own definitions, in your own words, define reflection and then line of symmetry. Go back into your class worksheet that you took notes with to define these. That might help. Okay, we're going to get into an example here. Identify reflections. Tell whether the red triangle is the reflection of the blue triangle and the line M. So is this our line of reflection here for these two objects? Is the image congruent to the original figure? Yeah. Looks like it is. Is the orientation of the image reversed? I mean, this is down here now. Yes. Triangle FGH here, it has a clockwise orientation. Oh, okay. And FGH prime has a counterclockwise orientation. Okay. Is M the perpendicular bisector of the segments connecting the corresponding points? Well, wait a minute. Here's M here. Is M the perpendicular bisector of the segments joining the corresponding? We have M here connecting the corresponding points. So to check, draw a diagram and connect the corresponding endpoints. So in this case here, we have perpendicular here that joins G prime and G, and then F prime and F would be a perpendicular, not a bisector, perpendicular bisector of the segments. Well, I guess it's equidistant from M here on this perpendicular, so I guess in that respect it would be. And then H over here, we have H and H prime. So that they would be perpendicular in that respect. Yes, And then answer, because all three properties are met, the red triangle is the reflection of the blue triangle. So we draw a perpendicular off of M and then put the point down here that's equidistant up here from M down here. And then same thing here, H from H prime, and then F to F prime. It would be the same distance from M here. Okay, determine whether the red figure is a reflection of the blue figure. Number 1, students, teachers, determine whether the red figure is a reflection of the blue figure down here. Give your students 5 minutes. Okay, welcome back. Yes, all three properties of the reflection are met. So we draw a perpendicular off of M, and then we make sure we measure them, and they do appear like they are the same. And then up here, no, the orientation of the image is not reversed. It's not reversed. So it should be turned around instead of pointing in the same direction. It would not be a reflection. It would be a shift, it's a translation. It would not be a reflection. Okay, moving on now to example 2. Identify reflections. So tell whether the red triangle is the reflection of the blue triangle on line M. So what about that? Is the image congruent to the original? Yes. Is the orientation of the image reversed? No, it's not. It's just been shifted over. The red triangle is not a reflection of the blue. Okay, going to our guided practice here. Determine whether the figure in red is a reflection of the figure in blue. Explain why or why not. And same thing down here. Explain. Teachers, give your students 3 or 4 minutes. Okay, welcome back. No, the orientation is not reversed. I mean, if that was the case, this would be over here. I mean, drawing a perpendicular here, you would measure, this will be the same distance over here, and it's just a shift. Now over here, number 1, yes, all three properties are met. So if we drew a perpendicular here, they'd be the same distance, and out here, same, and then here it would be the same. So that'd be how you would do that. And that was part 1 of lesson 5.7. Part 2, part 3 would be here. Thank you.